So we are back, and this is lecture number 1 in ray optics. One of the topics after thermo, which we all know that is very productive. And again, most of the things that you will find in this chapter only depends on how much you can remember in terms of formulae. Again, the number of formulae are very less, but there are different variations of the same formula. If you can remember all those variations, if you can remember the meaning of all those terms, then you will have enough scoring opportunities in this particular topic, in this particular chapter. As the name suggests, this is ray optics. Ray optics. Optics means the branch of physics which deals with light. Optics. Ray optics. Here we are assuming that what? You know that light has got dual nature. Yes or no? We have done it in the chapter on photoelectricity. Light has got dual nature. It can act like a wave. It can act like a particle. Yes or no? Now here, when we are treating light as a ray, we are basically trying to treat it as a particle that they are moving in straight lines, right? So it may be called somehow like we are dealing with the particle nature of light only. Though you must understand that reflection of light can be understood by particle nature. It can also be understood by wave nature. Reflection is how we start this chapter, and you all would be knowing what you mean by reflection, because this is one thing I think which you have studied from standard 6, 7, 8, 9 or 10. Yes or no? No or yes? Yes, we have seen this. Can you tell me what is reflection? Obviously, you cannot speak because you don't have a mic, but reflection. Now, the definition that you would have heard about reflection is very true. No points of undermining that definition. That would be correct. The definition that is given in the sheet, when a ray of light, when a ray of light falls on a reflector, what is a reflector? A reflector is a perfectly reflecting body. Reflective power is 1, transmittive and that absorptive power is 0. It will bounce and it will come back, will bounce back. This phenomena is known as reflection. Do we understand that? Can I have some raised hand that we understand this? Now, this is a very basic definition of reflection, but if I have to give you a more elaborate definition of reflection, and that might cover the definition of the other term that is going to come, that is refraction as well. So definition that I would probably create would be somehow not different, but somehow more elaborative, because I always believe in giving you the most elaborate definition which covers all aspects of the topic. And the definition that I am going to give you is like this: reflection. You don't have to understand, you don't have to write the definition, just understand it. Now remember, I have drawn this line. Now this line could be a mirror. If I make it catch, it becomes a mirror. This is the polished part of the mirror. We understand this, yes or no? It could be ground, it could be anything. Mirror. If I don't make it catch, it may not be a mirror. So I will take down this catch. Where did this touch go? Okay, I'll just rub everything off and I'll just draw this line. Now, when I'm drawing this line, now this line can represent kach. That is your mirror or reflector, or this could represent a boundary. And that is how I can make a very elaborate definition of reflection and the things which are coming off. This is a boundary. Boundary between what? Boundary between two medium. This is medium number 1 and this is medium number 2. What do you mean by medium number 1 and medium number 2? You look at the surface of water. Above that surface, there is air. Below that surface, there is water. So the surface of water or surface of lake or surface of a pond or the surface of an ocean becomes the boundary between water and air. Water is a medium, air is another medium. Do we understand this? Now, how do I make an elaborate definition? Now, on this boundary between two mediums, I draw a line which is perpendicular, which is known as the normal. Yes or no, we understand this? Okay. So my definition of reflection goes like this. When light or any wave strikes, Counter-Strike. Counter-Strike used to be a very famous video game. Now it's a PC game. Counter-Strike. So whenever light or any wave strikes the boundary between two mediums, or it strikes a mirror, or it strikes a reflecting surface, or it strikes a wall, whatever you call it, boundary is the next term. When light strikes, and this is the lightning which is striking. When light strikes, this is known as the incident ray. Do we know this? This is not the incident ray. We know this or not? And this is known as the angle of incidence. Yes or no? This is the point of incidence P, where the light is striking the boundary. This is known as P, is known as the point of incidence. These are all 7th, 8th, 9th, 10th standard definition that I'm telling you. So whenever light strikes the boundary between two mediums, what happens? What can happen? Now, everyone is tired of the class. So whenever light strikes the boundary between two mediums, what happens? We've already seen that. When radiation was striking on a body, what was happening? Either the radiation was getting reflected, or it was getting absorbed, or it was getting transmitted. Yes or no? Three things can only happen with radiation. Light is also a radiation, my dear friends. So whenever light strikes the surface, let us forget about it getting absorbed. Let us forget about it getting transmitted, because now transmission will be known as refraction. So we'll come to transmission, which is refraction. When light strikes a boundary between two surfaces, a part of it may not be the entire thing. If it is a pure reflector, it is the entire thing. If it is not a pure reflector, if it is a black body, everything will be absorbed. No, nothing will be reflected. So whenever light strikes boundary between two medium, a part of it will be bouncing back, is a term, or will be reflected back, or bouncing back, or turning back, or bending back into the same medium. Remember, both the mediums are same. That is the important thing. That's why I've created a boundary, and that is why I've created two mediums. When light strikes a boundary between two mediums, a part of it may be bouncing back into the same medium. This ray or this light is known as the reflected light, and this phenomena is known as reflection. This phenomena is known as reflection. The angle that it makes with the normal, where is my angle and where is my normal? The angle that the incident light makes with the normal is I, angle of incidence. The angle that the reflected ray makes with the normal is known as angle of reflection, and we all know that the angle of incidence and the angle of reflection are one and the same thing. I is equal. Do we understand how I have defined reflection? Now, A part of it is reflected back. A part of it will be absorbed. We are not talking about that absorption because we have talked a lot about black bodies. A part of it will be transmitted. That is known as refraction. A part of it will be going into the next medium. That is known as refraction or transmission. Do we understand this? We will be coming back to the definition of refraction, but right now let us concentrate our thoughts on what is known as reflection. Incident ray, reflected ray, angle of incidence, angle of reflection, medium number 1, medium number 2, boundary, and the point of incidence. These are the things that you should remember about reflection. I hope you have noted it down. Yes or no? No or yes? If you have noted it down, it is my humble duty to take your attention back to my small sheet. And again, you have not got this sheet. Probably you will get it today. So I'll just take your attention to this one and a very elaborative diagram that is been drawn. And here comes that diagram, and here comes that image. Laws of reflection. We have understood what is reflection. So what are the laws of reflection? This gentleman is law number 1. And what is law number 1? The incident ray, this one. The reflected ray, this one. And the normal, this one. All lie in the same plane. 8th, 9th, and 10th definition of reflection. This is my reflecting surface or your boundary between two mediums. Law number 2, the angle of incidence and angle of reflection are one and the same. Do we understand this? Please note down these two laws. I'll give you a minute to do it. Have we noted it down, Vita? Okay. Now remember, this angle of incidence and angle of reflection are equal, is valid for all types of reflection. Any reflection of any wave from any surface. Now this surface could be a plane mirror, which you can see it here. Plane mirror. It could be a curved mirror like this one, the convex mirror, or this one, the concave mirror. In all those cases, the angle of incidence and the angle of reflection are equal. I hope you understand the significance of this. Yes or no? Yes, sir. Now, here is one thing that is going to come over and over again, and I would like you to note it down. ASAP. In short, it is as soon as possible. In your generation, everything is in shortcuts. Sentences are in shortcuts. Every now and then I get onto some social media and I get to all sorts of shortcut. IMHO, in my honest opinion, all those things. It's very hard for me to understand them sometimes. Anyways, golden key point here. Remember this, and remember this, and remember this. When a ray is incident, normally that means it is along the normal, it is striking perpendicularly. It is striking perpendicularly. The angle of incidence is 0. The angle of reflection will also be 0. And therefore, the ray will retrace its path. Look at this one. The blue arrow that I've drawn is the incident ray. The red arrow represents the reflected ray. The ray is striking like this. Dong, 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 dong. It is coming back like this. Dong, 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 dong. The blue is the incident one. The red is the reflected one. Do we see this? Similarly, in case of a concave mirror, this is the center of curvature. What is center of curvature? Don't worry, we will get to the definition. Any ray which is passing through the center of curvature will be incident normally. So this is the 3 blue rays, which are the incident rays, which are passing through the center of curvature. And my dear friends, the reflected part is represented by these red arrows. These rays which are passing through the center of curvature, they are moving in a straight line. They are passing through the center of curvature, which is the center of the sphere, and all those things. They are always incident normally, and therefore they are retracing their path. Do we understand this? On the extreme right side, we have the convex mirror. What is concave? What is convex? We will all understand this. The center of curvature over here lies somewhere over here. The blue one is the incident rays. As you can see this. The red ones are our old friend, the reflected rays, and they are retracing their path. I hope that you have understood this and you are going to note this down. I hope you have noted it down, beta. Now the time that we move ahead in life, remember whatever small statements you are writing, they are questions, proposed questions that can come. Remember all these things. You may not know the meaning of all those terms. I'll try to make you understand the meaning of all those terms. The frequency, wavelength, and the speed of this light does not change on reflection because it is moving in the same medium. Remember point number 1. Intensity, energy falling per unit area, per unit time, and the amplitude, it can only decrease or it can only remain same depending on the nature of the surface. Now I would like to just give an example. Now that is how questions would be framed. Now if you have a perfectly reflecting body, and please may I have your attention, if you have a perfectly reflecting body and the entire ray is getting reflected, none of it is getting absorbed, none of it is getting transmitted, in that case the intensity and amplitude will remain same. Do we understand this? If the ray is completely reflected, if it is a perfectly reflecting body, the amplitude and the intensity will remain same. But if it is not a perfectly reflecting body, it absorbs some part, it refracts or transmits some parts, or it is a perfectly absorbing body. If it is a perfectly absorbing body, the reflected ray will not be there, so the amplitude will be 0, intensity will be 0. If it is not a perfectly reflecting body, it is a combination of, it has got reflecting power, it has got absorptive power, it has got transmittive power, then the amplitude and the intensity of the reflected ray will decrease. Do we understand this? How much will it decrease will depend on how much it is reflecting. If it is reflecting more, it will decrease less. If it is reflecting less, the amplitude will decrease more. Do we understand this? Then there is a phase change of 180 degrees or pi radians when it is reflected by a denser medium, but it does not occur any phase change when it is reflected by a rarer medium. What do you mean by a denser medium? For a denser medium, mu, which is the refractive index, is high, and for a rarer medium, mu is low. Now, what is this denser medium and what is this rarer medium? I will be discussing these two mediums in a lot of detail in the topic of refraction. Just now, for your information, just remember, if the light is reflected by a denser medium, so on one hand I have rarer medium, this is the boundary between two mediums. Here is medium number 1, here is medium number 2, this is rarer medium, this is denser medium. Light is going from rarer medium to denser medium, so it is getting reflected from this surface. In that case, when it is getting reflected from a denser medium, it will undergo a phase change of pi. It will undergo a phase change of pi. It will undergo a phase change of pi. That means you must know what is crest. Do you know what is crest? A crest will be reflected as a trough, and a trough will be reflected as a crest. That means it will just reverse. Crest is the highest point of the wave, trough is the lowest point of the wave. So lowest will become highest, highest will become lowest. That is what we call as the phase change of pi. Do we understand this? So these are the three things that you must remember about reflection. What are those three things? Number one, the frequency, wavelength, and speed will not change. Number two, intensity and amplitude depends on the nature, how much is the reflecting power. If the reflecting power is more, amplitude and intensity will decrease less. If the reflecting power is 1, amplitude and intensity will remain same. There will be a phase change of pi degrees. Oh, sorry, pi radians when it is reflected by a denser medium, when it is reflected by a rarer medium. It does not undergo any phase change. I will end the class today on this note on basic introduction of reflection. In the coming class, that is tomorrow, we will dive deeper into reflection, starting with plane mirrors. I hope you get the sheet by today. The mistake on my part that I had already attached the document, but I forgot to push the send button, so it never got sent. So the office people never got it. So it's a failure on my part. It's a mistake on my part, and I take back my words that now I have sent it. It has been received at the other end, and probably you would be getting it by today. So I'll shut down the class today here. We will get back on reflection tomorrow. I hope I'll see you tomorrow. Take care and have a very, very nice day. Bye bye.